Hello Gators, this is a hint on how to do 3 problems on the circuit. I'm giving you the answers, but those of you who are curious as to how to do it, I am giving an explanation. Okay, the first one is a cosecant of 2x. Cosecant of 2x has a fancy trick, and the fancy trick I showed in the other video, so all I'm going to do is show you how to use this idea right here, how to do that. So we can see that we have just an x here, so we're going to let u be equal to 2x, and we're going to do du dx, that will be equal to 2, and du will be equal to 2 dx. Now you can see I have a dx, but I don't have a 2 in it, so I'm going to take it to the other side. All right, now I have a substitution for dx. The substitution is 1/2 du, and I have a substitution for 2x, and that is u. So now I'm going to rewrite the problem, and I'm going to do integral of cosecant and instead of writing 2x, I am going to write u. And instead of writing dx, I'm going to write 1/2 du, but I'll put the 1/2 outside and the du here. And so now it looks a lot like this formula. So I'm going to follow this formula. I have to have a negative. There's a 1/2 my multiplier. So it'll be negative 1/2 natural log of the absolute value of cosecant u plus cotangent u plus c. And now I found my antiderivative in u, so I want to go back to x's. And so this will be with a 2x plus cotangent of 2x plus c. And that's your first hint. It's located on page 2. The last 2 hints are located on the last page, and I'll go ahead and do it again following the format here. I can see that it looks a lot like this one, integral of tan x dx, but this is just a plain old x, and I have a 4x here. So I'm going to let u equal to 4x. So du dx will equal to 4. Du, bring the x to the other side, 4 dx. I only have a dx, so I'm going to take that and take it to the other side. Okay, so now I have a way to replace dx. I will replace it with that, and I have something to replace 4x. So now this is going to be tan of u times, and dx is 1/4, I'll bring it out here, du. Now it looks a lot like this problem, so I'm going to write 1/4, and then that'll be, I have a negative, because there's a negative right there in the formula, natural log of the absolute value of cosine of u plus c, because this was in terms of u. And this will be negative 1/4 natural log of cosine, and I'm going to resubstitute u for x plus c. Okay, your last hint is going to be this one, and this comes from our inverse trig formulas. It's a lot like this one right here. Okay, so I want to make it look a lot like that. So first order business, I am going to pull the 3 out, and I am going to have dx up here over root. I'm going to make it look like a square minus a square. So this is 3 squared minus 2x squared. So I want to make it look like that. I'm going to let u be my variable, 2x. Du dx will be equal to 2, and then bring the dx to the other side, and I can see I don't have a 2, so I'm going to take that 2 to the other side here. So now I have a substitute for dx, and I have a substitute for 2x. So now this is going to become 3. I think I'm going to run out of room, so let me go ahead and go down here. So I'm going to write 3 integral, and my dx is going to be replaced with 1/2 du. I'm going to bring the 1/2 out here, and I'll write the du up here, and then this will be root 3 squared minus u squared. So now it looks a lot like this. A du up here, a squared minus u squared. So here's my multiplier, 3 over 2, and then this will be sine inverse parentheses, and my u, remember, is a 2x, and my a is the number, a was the number 3. I should have put it up here, but a was 3. That was that number there, 3. And then plus c. And there's your answer. So hopefully these will help you get through your circuit.